Hey guys, we are going to run through your notes referring to blood spatter. Now, whenever you talk about like paint spilling or spraying, we talk about it splattering. But whenever we are talking about blood, it is not a splatter, it is specifically a spatter. So there are two different terms, whether you're dealing with paint or something else versus blood. But looking at blood spatter, it's the patterns left by falling, projected, or smeared blood can be used to interpret or reconstruct what happened at a crime scene. Depending on what type of blood patterns we see, we may be able to figure out what type of crime occurred, where the person was standing, different things like that. These can be used to prove or disprove a suspect's account of what happened. So kind of make sure that the facts of what they heard or what they witnessed add up. And looking at the observation of the position and shape of patterns can be used to find things like the direction of travel, where that blood came from, the angle of impact, which can also give us an idea of exactly where it came from, the position of the origin of this blood came from a victim, where was the victim standing at that point in time. We can also determine the speed at impact, which could be used to determine what type of crime occurred. So looking at how we describe blood stains, and there are a lot of kind of terms here that we look at. One of those is the angle of impact. This is an acute angle, so remember acute angles are less than 90 degrees. This is formed between the direction of the blood drop and the plane of the surface it strikes. So I do have an image of it down the bottom left, where we have a blood drop coming in and striking a surface. We can measure that angle that it comes in at, and that's something that we'll actually do later in the notes. We also have an arterial spurting pattern. This is a blood stain pattern resulted from blood exiting the body under pressure from a breached artery. So within your body, you have arteries, which are going to be those larger blood vessels that are carrying blood to like your arms, your legs, things like that. And then you have veins, which are those smaller blood vessels. With an artery, blood is moving through these very quickly. So if someone has an artery that is breached, the blood will spray out with every heartbeat. So it'll kind of spray, stop, spray, stop, spray, stop. And it is under a lot of pressure because there is a lot of blood flowing through there at the time. So it tends to have this pattern like we see in the middle picture in the bottom, where it's erratic, it's not a continuous spray, and there is simply a lot of blood with these type of incidences. We also have back spatter. We're going to talk about there's back spatter and forward spatter. These tend to be related to some sort of weapon impact. Back spatter is going to be blood directed back toward the source of energy or force that caused the spatter. So it will be going towards the location of the weapon itself or the offender itself. So if you look at this picture in the bottom right, this is an image of a shooting. So we have the gun over in the left, the victim or their head in the middle. So notice that when someone fires the weapon, it is going from left to right here. Notice that some blood comes out the front of the head back towards the gun and towards the offender. That is that back spatter. Same thing would happen with a knife wound or something like that. That blood is going to be directed back towards the knife or the offender. Blood spatter analysis is its entire branch of forensic science. So it's a field of forensic science that deals with the physical properties of blood and the patterns produced under different conditions as a result of various forces applied to the source of blood. So they look at how blood travels, how blood flows, what creates different patterns of blood, and things like that at a crime scene. A blood stain is evidence that liquid blood has come in contact with a surface. So any trace of blood in a crime scene is going to be considered blood stain. One of the specific types of patterns that we look at are cast-off patterns. This is a bloodstain pattern created when blood is released or thrown from a moving blood-bearing object. So looking at the picture on the right, so here we have a baseball bat that is hitting our victim. Once it hits our victim and it has blood on it and it is drawn back, that blood is going to be flung off of the bat whenever it is flung back again. So it will create kind of an arc shape with different blood stains in it. I also have an example of cast-off patterns on the left. A lot of times we can use that cast-off pattern to determine what weapon was used. So here I have the top set of patterns are from a pipe. The bottom set of patterns are from a pool cue or a pool stick. These are both fairly cylindrical objects. Notice that the pipe is likely thicker than the pool cue, so it actually sprays off larger drops than the pool cue does. So looking at those patterns and comparing different weapons, we can actually narrow down what weapon was used in a certain case. We also come across contact stains. This is blood deposited from direct contact between two surfaces, at least one of which is bloody. So this is if someone steps in blood and continues walking, you're going to see their bloody footprint every other step. That is considered a contact stain. Same thing if someone has blood on their hands and they go to touch the doorknob and open it. That fingerprint that is left behind is considered a contact stain. One thing that we'll be measuring and looking at is direction of flight. So the trajectory of a blood drop, which can be established by its angle of impact and directionality angle. So what it means by directionality, which is the next term, is a blood stain or pattern that indicates the direction blood was traveling when it hits a target surface. And this can be found by looking at the geometric shape of the blood stain. So what happens is when blood comes in and hits a surface, some of the blood sticks where it hits and some of it continues moving. So you end up with this little tail indicating the direction the blood is traveling. So if you look at those images in the middle, notice that these blood stains do have a little tail. Wherever that tail is pointing shows you the direction that blood was traveling in. Same thing with the image on the right. If it's a blood drop that is dropped straight down, there's no direction. But if it is that elongated shape and it has a little tail, the tail tells you the direction that blood drop was moving in. We also have drawback effect. This is going to be with gunshots and things as well. But with drawback effect, we're going to find blood in the barrel of a firearm that's been drawn back inward into the muzzle. So whenever a gun is fired, that bullet leaves the chamber and goes through the muzzle of the gun, also pushing air out of that space. Well, air is going to be pulled back into it to fill in that space. When that occurs, if they're close enough to the victim, blood droplets can get drawn back into the weapon itself. We also encounter drip patterns. These are going to be from more passive drops of someone cut their finger and it's just dripping straight down on the ground and things like that. But this is going to be a blood stain pattern resulting from blood dripping into blood. So this is demonstrated by the picture in the bottom left. We have blood that was dropped, but as it continues to drop, it hits those previous blood drops that are there and creates kind of a spray effect. It kind of is no longer in a circular pattern. They merge together whenever there's multiple drops, and it's more irregular overall. Another thing we can counter is expirated blood. This is blood that's going to be blown out of the nose, mouth, or a wound as a result of air pressure flow. So think of, if you've ever had a bloody nose and you go to blow your nose, you're blowing that blood out of your nose. You're not typically supposed to do that, but it can occur. If someone is hit and they have blood in their mouth, they go to spit it out. That spitting action is creating an expirated blood pattern. Same thing if someone has a wound and it's near their lungs or it punctures their lung. Whenever they breathe, air is pushing blood out of that wound itself. We also look at flow pattern. This a lot of times we're going to see whenever blood is on a vertical surface, like a wall, things like that. So it's going to be a change in the shape and direction of a blood stain due to the influence of gravity or movement of the object. So this picture is depicted in the bottom left. There's blood that's on the wall. Well, gravity is pulling that down, so you're going to see a trail of blood moving downward. Same thing if this was on the outside of a car, as they're driving a car, it's going to get pushed back on the car itself. We already talked about back spatter. Forward spatters blood that's traveling in the same direction as the source of energy or force that caused the spatter. So whenever someone fires this gun, the bullet is moving forward. So all blood that moves forward is considered that forward spatter. It's going in the same direction as the bullet is. We also talked about with blood patterns, you can determine kind of the speed that was occurring at. And a lot of times it's either going to be considered high velocity, medium velocity, or low velocity. High velocity impact spatter, or HVIS for short, is a bloodstain pattern caused by a high speed impact or force to a blood source. So this is something that is moving very quickly, such as like a gunshot. The velocity of the blood can be 100 feet per second or higher, and the drops tend to be very small. So here drops are going to be less than or equal to 1 millimeter. So you're going to have a lot of drops that are smaller in size, like this image on the right. We have impact patterns. This occurs whenever blood receives a blow or force, resulting in the random dispersion of smaller droplets of blood. So someone already has a head wound and then they're hit again with a weapon. When that weapon comes in contact with the blood that is already there, it's going to spray out in all directions. Similar to the picture on the left. Here we had a source of blood, we hit it, and you see these sprays going off in every direction. The impact site is the point where force meets the blood source. So this is where, like, the baseball bat will hit the individual's head. That is the impact site. Laura said high velocity impact spatter was moving very quickly. It results in very tiny drops. Kind of the complete opposite of that is going to be low velocity impact spatter, or LVIS for short. This is a bloodstain pattern caused by low speed impact or force to a blood source. Okay, sorry about that. So it's low velocity impact spatter, or LVIS for short. This is a bloodstain pattern caused by a low speed impact or force to a blood source. So this is going to be something that is moving up to 5 feet per second, so moving much slower. So this could be where someone like falls on something sharp, and that impact could create a low velocity impact. It could be someone is hit with a fist, things like that. These are going to have drops that are anywhere from 4 to 6 millimeters across. So drops are going to be much larger, and we're overall going to have less of them. So you can see an example of the low velocity on the right. So notice that it has less drops than the high velocity we looked at, and they're much larger. We also come across medium velocity impact spatter, or MVIS for short. These are, yet again, kind of in between. So this is going to be a bloodstain pattern caused by a medium speed impact or force to a blood source. So this could be like that should say a beating. It could be a stabbing, things like that. So moving a little bit faster, velocity is going to be up to 25 feet per second. And these stains are going to kind of be in between. They're going to be anywhere from that 1 to 4 millimeter range. So this is depicted on the left. So notice that these drops are smaller than the low velocity, but larger than high velocity. And there's also kind of an amount that's in between. With some cases, we end up with misting. Misting occurs a lot of times with explosions and things like that. So if these blood's been reduced to a fine spray as a result of the energy or force applied to it. So it's such a powerful force that essentially breaks up those blood droplets. This is shown in the picture on the right, where close to that impact, you can't necessarily see individual drops. It's just kind of a red or a pink smudge, which is where it's misted and you're not seeing the individual droplets. We have passive drops, which is just bleeding with gravity. So these are blood-stained drops created or formed by the force of gravity alone. So it's not moving. There's not necessarily an impact that is causing this. So this is, your nose is bleeding and it drips straight down. These with drops that are very passive and dropping straight down are going to be very circular and not really have any tails or things like that. We're also going to encounter parent drops and then satellite spatter, which come from a parent drop. So parent drop is a drop of blood that casts off a wave or satellite spatter. So this is going to be like the first blood drop that occurs. Now, and then this can spray into other droplets if it's from a high enough up, or it might be the blood drop that was there first and then other blood drops into it, creating spray. Those little sprays that come off of that parent drop, we're going to refer to as satellite spatters. So think of satellites are around the Earth. Satellite spatter are going to be blood droplets that are around a larger droplet. So these are going to be small droplets of blood distributed around a drop or pool of blood as a result of blood hitting the surface. So there's kind of two ways that you're going to see these. If you look at the image, it's in the middle, but towards the top. Here is more of a passive blood drop. It's more circular, it's straight down. But it was dropped from high enough that whenever it hit the surface, it sprays out, creating these little spines and satellite drops going around it. This can also occur whenever we have a blood drop coming in at an angle. These are going to be those tails that are attached. So you can see the picture at the far right. These are blood drops coming in at an angle. Remember, when it hits, it elongates, and we get the little tails that form. Some of those tails separate completely and become a satellite. And you can also notice this in the picture that's in the middle but at the bottom. We have a blood drop traveling in this direction. It hits and elongates. The satellite blood pattern comes off of that one, and it is kind of reversed. So if we're looking at a satellite spray, the little tail of it points from the direction it came from, whereas majority of the time the tail points with the direction of travel. Whenever we are at a crime scene and trying to kind of map out where the victim was, where the offender was, things like that, we can find the point or area of convergence and point or area of origin. The point or area of convergence is the common point on a two-dimensional surface, so on a flat surface over which directionality of several blood drops can be retraced. So this might be looking at blood drops that are on the floor and tracing them back to where on the floor did these come from. This is depicted in the left picture. We're looking at all the blood drops on the wall. They're kind of looking at where they came from, connecting them together to figure out exactly where that convergence area is on the wall. Whenever we're looking at the pointer area of origin, this is going to be looking three-dimensionally. So where within the room did this blood spatter come from? So it's the common point in a three-dimensional space to which the trajectories of several blood drops can be retraced. So this not only looks at the direction the blood drops came from, this also accounts for that angle of impact so that they can make these lines, or sometimes they'll use strings, see where that blood came from, and that kind of common point is going to be that area of origin in that three-dimensional space. So that can tell them how far away the victim was from the walls and things that contain this blood spatter. With blood drops, we also have spines. Like I said, these are also referred to as like tails. This is the pointed or elongated stains that radiate from the central area from a blood stain. So looking at the blood drops that are on the bottom left, here we have more of a passive drop that when it came down, we have all these little spikes coming off the side. Those are going to be our spines. Whenever we have a blood drop that is coming in at an angle and it elongates, that spine is that little tail that is attached. Whenever we're looking at contact stains, we also have swipe and wipe patterns. So swipe pattern is a transfer of blood from a moving surface onto an unstained surface. So this means that I have blood on my hands and I touch a clean surface and deposit that blood onto that clean surface. With these, the direction of travel can be determined by the feathered edge. This is depicted from that picture in the middle. We have where the blood is darkest, kind of up towards the tip of the fingers right here. That is where I first made contact with the wall, and then my hand went down the wall, swiped down the wall, and then it gets lighter. So notice that it feathers and gets lighter at the bottom. So here my hand was moving down the wall to create that swipe pattern. We also have wipe patterns. This is where there's a blood stain that is already on an object, and then you have an object that moves through that existing blood stain, changing its surface. So here, there were blood drops that were already on this surface. You can see them, even ones that are distorted, you kind of see that halo of where the original blood drop was. This is where someone's hand went through blood that was already there. So you see the original parent drops, and then you see the hand went that way through the drops, creating those tails that are feathered at the end. But blood was already on this surface with a wipe pattern. Whereas with a swipe pattern, there's a bloody surface moving on a clean surface. So that's kind of the difference between the two. We also end up with transfer patterns. These are pretty synonymous with those contact patterns. So these are blood stain patterns created when a wet, bloody surface comes in contact with a second surface. So yet again, where you're tracking bloody footprints or someone touches something with a bloody handprint. And you should end up with a recognizable image of all or a portion of the original surface in the pattern. So kind of going from the left, here we have a shoe print. So notice you can see those ridges and stuff in the shoe print itself. The next one is a handprint. So you can actually see the outline of the palm and the fingers through that pattern. We're also going to come across voids. Voids can tell us a lot if something was moved at the crime scene or removed from the crime scene. So a void is an absence of stains in an otherwise continuous blood stain pattern. So it's kind of like a shadow, but it's looking at what object was there that kept blood from depositing in that area and then was likely removed. These are shown in those two pictures on the right. So notice in the second to the right, or second from the right, excuse me, there are blood drops everywhere, and then there's this kind of blank space in the middle. If we trace out that blank space in the middle, excuse me, I'm having to use my mouse for this. So if we kind of trace this out, we can see what object was here that was removed. So that looks like the head of a wrench. So there was a wrench laying here whenever all the blood around it was deposited, and then someone picked it up and moved it. Same thing in that picture on the far right. Here we have a lot of blood, but there is an empty space, a void in the middle, that if we trace it out, excuse me, matches the shape of this hammer. So this hammer was here when the blood was deposited, and then someone picked it up and moved it. So the absence of blood can also give us clues. I've heard cases, and you've seen this on crime shows and stuff, where maybe there was a person there, and whenever blood was sprayed, it got on that person, and then there's this empty spot behind where they were standing. So this may give them a clue of if there were multiple offenders there looking for voids where blood was not able to spray. So how do we further analyze a blood pattern? This is going to give us an idea more of where that area of convergence and that area of origin are. One thing that we look at is find the direction of those blood drops. So remember, we're looking for those tails where the blood drop is elongated. That gives us an idea of the direction of travel of the blood drop. We can guesstimate the height by the drop size. We're actually going to do this with lab later on this unit. And you'll notice that generally whenever you are dropping blood from a higher height, it tends to spread out more and become a larger drop. You may be able to tell if the assailant was right or left-handed by where those cast-off patterns are. Like if you can tell where the person was standing, if all the cast-off patterns are to the right of where that person was standing, they're right-handed. If all the cast-off patterns are to the left, that individual was left-handed. One of the things that we are going to do with a lot of these is to find the impact angle. This is going to give us an idea of, in that three-dimensional space, where the blood drop came from. And we actually have to calculate this. So the formula for it, and it doesn't let me type it very nicely, but it's the arc sign, which is that sign -1 on your calculator. So that sign -1 of the drop width divided by the drop length. So in general, it's like a smaller number divided by a bigger number, always. But the drop width divided by the drop length. When you input that, that gives you that angle of impact. And one thing to note is whenever we are measuring blood drops, we do not include any of those extensions or spines. So to show you how this looks, let me see if I can manipulate this at all. Here I have two blood drops. We have one that's very circular, so this is most likely from a 90-degree angle. Oops, excuse me.